We're just going to ask you 2-3 really quick questions on unit circles. Relax, it's the same as like if you were having a unit circle quiz. What is sine of pi over 2? Sanchez, you want to, don't worry, take your time. Sine of pi over 2. Heck yeah, it's 1. All right, let's see. What is cosine of pi over 6? Ms. Hernandez, take your time. Cosine of pi over 6. And it's a safe space, so it's okay if you don't have it right. Heck yeah, it's square root of 3 over 2. Good job. So I think all of you would have maybe gotten 100 maybe. I don't know, we'll see. But next time we meet, we'll have a unit circle quiz, first 10 minutes of class. So yeah, so we have a packed day today, guys. So let's get right into it. So we have been talking about sinusoids and how to graph sinusoids, and I think we're okay. I think we're pretty good. You guys know that a sinusoid is just a wave, and we can write an expression for this wave using either sine or cosine. But guys, these rules you've known these rules all your life, or at least since 7th grade. It's the same rules from Algebra 1. It's the same rules from Algebra 2. So I have a sinusoid here, and I stole this image from Delta because you can see the outline is just the same. So I'm giving Delta credit. So yeah, here you go. And I just took a screen capture and I put it here. And what I want that dashed line. So this bold line is your parent function. And that parent function it goes right through the origin. So take a guess. What do you think that parent function is? Is it sine or is it cosine? Yeah, it's sine x, because sine x is the one that goes right through the origin, and that's the point of inflection. So I have sine x. So what I want is this dashed line using sine x. So I'm just going to write my expression. I'm going to go down the alphabet. Y equals a sine, open parenthesis, b, open parenthesis, x minus c, close, close, plus d. What does the a stand for? Amplitude. What does the C stand for? You guys remember? Starts with, yeah, you can say use the word starts with an S. Second letter H. Ooh, third letter I. Shift. What type of shift? Horizontal. It's just like when you guys were in algebra, guys. That's a horizontal shift. Now, sometimes they will call it a phase displacement. That's just a fancy word. Chav, why do they call it phase displacement? Because we're dealing with a wave, and waves have certain tendencies. But it's the same thing, guys. Horizontal shift, phase displacement, same. Now, the last letter here, D, what does that stand for? The midline. Guys, it's the same as a vertical shift when you guys were in algebra. It's the same. What does midline mean? It's in the name, midline. It's the middle of this wave. So it cuts the wave in half. Yay or nay? Okay, so how do I tackle this? I think the easiest way is to work from the middle and get everything else. So how do you find the middle of anything? Well, you add them and divide by what? 2. That's how you find the middle of anything, guys. So to find my midline, I take my high value. What's the high y value? What is it? The high y value? 5. And then I add my low value. What's my low y value? -1. And I take that and I divide that by 2. 5 plus -1 is... What's that? Not everyone at the same time. Yeah, 4. And 4 divided by 2 is... So that's your midline. So it helps to sketch in that midline. Are we still okay? All right, so here we go. My amplitude, the distance from the midline to the high point, the difference between high minus middle. You could also say the difference between middle minus low. So what do you think the amplitude is? 3, perfect. My phase shift, I'm looking at sine. I want a sine curve, so I don't want a cosine curve. So I need to find a point of inflection where this curve is increasing. So give me a point of inflection where this curve is increasing. Give me one to the left of the y-axis. Yeah, -pi, or you could also give me one to the right of the y-axis. 3 pi. It does not matter which one you use. Both are correct. in case you're wondering, Chav, I don't understand what you mean. Imagine that I could drag this curve from this point to this point. It will look the same, guys. Because it's still increasing. Everything is periodic by nature. So because it's periodic by nature, it would be the same peak. It would be the same minimums. Everything would look the same. So there it is. I got everything I need. The only thing I don't have is the B. Now, here's sometimes where we can become robotic. And I'm going to explain something in a little bit that hopefully you make a connection to your algebra days. Give me a formula for how to solve the B. How do I get the B? So 360 divided by period. If that's in degrees, do I have degrees here? I have radians. So instead of 360 degrees, 2 pi. So 2 pi divided by the period. And the period, let's see, I have a peak at 0 and I have a peak at 4 pi. So the difference between 0 and 4 pi is 4 pi. So 2 pi divided by 4 pi, that's just the same as what? No, not pi over 2, but it's you're good. You're good. Well, yeah, 1/2. 2 pi, the pi's cancel out. 2 goes into 4 twice, right? So 1/2. So here we go. Here's my equation. Y equals, hey, Ochoa. Y equals, your amplitude is, what was your A? I already lost it, 3. And then sine, parenthesis, 1/2, open, x minus, what was your C? We said pi, so plus pi, close, and the D was 2, plus 2. I think everything is correct there. I know that I told you I was going to talk about that 1/2 in a little bit. We will. Just, give me a second. Let's type this into our calculator, guys, into your Y1. So here's your calculator. The Y equals button is in the top left. And I'm just typing that expression in exactly. So what was that expression again? 3 sine. I'm going to push the alpha Y equals to get a little fraction. And what do I have as a fraction? 1/2. And then I open another parenthesis. And then I go x with the plus pi. Yeah, close. And then plus what? 2. Don't push graph yet. Look at this window. I'm going to make my window look like this. Notice the leftmost x value is negative 2 pi. So I click on window, and where it says x min, put negative 2 pi. Notice my biggest x value, it looks like 8 pi. Do you guys see that? So go to window, where it says x max, put 8 pi. X scale, notice that the scale here goes by pi. Pi, 2 pi, 3 pi, 4 pi, 5 pi. So for x scale, I'm going to put by pi. Y minimum, let's see, what's the lowest y value? Negative 5 on the grid, on this grid. Negative 5, so I'm going to put negative 5. Y max, what's the biggest y value? 5. I'm going to go a little higher because I want to see the little peak. So I'm going to put 6. And then my Y scale, I think it goes by 1. Yep. And then I push graph. And if it doesn't look like that, check your mode. We're in radian mode. Let me put my midline in here. What was my midline 2? So I'm going to go to Y2 and I'm going to put 2. I'm going to push graph. Now, how do you check to see if you have the right values? Well, I know that I have a point of inflection at negative pi. So check it out. I push the trace button and put negative pi, and I push enter. And look at that. It's right on that point of inflection. All points of inflection happen at the midline, all of them. I know that I have a peak at 0, so I push 0 and I push enter. Oh, look at that. It says 5. I know that I have a minimum. Let's see, where's my min? At 2 pi. So if I push 2 pi, OMG, look at that, negative 1. Now, if you're thinking, Chav, when am I ever going to use this in real life where I have to insert this into a calculator and graph? And guys, it's not necessarily the expression that you're going to be using in your entire life. It's a skill, right? You guys are going to be the nurses. You guys are going to be the future doctors, the future engineers. This could very easily be a heartbeat, and you're the one that has to calibrate that machine to show that phenomena, that heartbeat that goes over and over in a window that makes sense to you where everyone can see it. So it's the skills that it's going to transcend into everything, guys. So make sure that we know how to critical think, that we know how to analyze, that we know how to calibrate. How do we feel? Do we feel okay? Nothing crazy, right? All right. I wanted to bring your attention to this half. When you were in Algebra 2, and this is why I put right here, let's talk about that behavior. When you were in Algebra 2, what did Miss Torres or your previous, I know she told you because I saw her lesson plan. What did Miss Torres tell you about what that 1/2 does when they put it like that in front of that expression? Do you guys remember? Let me give you a hint. It's either a horizontal stretch or compress. Do you remember which one? You think it's a compress because it's smaller than 1? It does the opposite, or the inverse, I guess, technical, because opposite means if it's positive, it's negative, it's positive. So it does the inverse. So if it's a compress, if it does the inverse of compress, what do you think it does? It's a stretch by a factor of 2. So let me write here, horizontal stretch, and I know you guys did it because I saw that activity itself. Horizontal stretch by a factor of 2. By the way, this is a famous ACT question. So if you just took the SAT, ACT, I'm sure that question probably came up in the non-calculator section. I want you guys to observe something. So I'm going to make something up real quick. This is not in your notes. I'm going to go to my little school-sponsored laptop here. So let's see. I'm going to go to Desmos. I just want you guys to see something. And I don't expect you guys to be able to do this cold turkey. Not yet, because we're not doing programming. But let's talk about an easy function for everyone. You guys know about quadratics, right? So I'm going to talk x squared. Simple graph, right? Simple graph. Okay, look what happens when I'm going to go g of x. And because this is already kind of dealing into programming, guys, if you guys have computer science, this is Desmos is smart enough, since I named this function f of x, I can recall f of x. So I'm going to go f, and now check it out. I'm going to put a, let's see, I'm going to put a half. No, because that's going to stretch it. No, I want to stretch it. I'm going to put, I'll put a half there. Let's see, half of x. And look at that. Do you see that blue curve? And I know what you're thinking, like, okay, child, how do I know that that's a stretch or compress? Well, imagine that the x-axis is something you could pull. If I could pull on the x-axis, that would try in Algebra 2, you're like, oh yeah, horizontal stretch by a factor of 2. I just wanted to connect that to your algebra day, guys. Hopefully that made sense. Hopefully we're not robots now. Like, you can always use formulas. That's fine. But eventually your memory will fail you guys. And I'm not saying that I don't want anyone's memory to fail you now, but sometimes I even forget I don't even remember what I did this morning. I ate a taco and I'm not sure what type of taco it was. That's a lie. I remember what taco it was. But you guys understand what I'm trying to say, guys? If you understand the concepts, you can always figure stuff out. You can always think critically, okay, what's going on? Why is the behavior this way? If you know what's happening underneath all these formulas, then you're already ahead of the game. You will score really high on the SAT, ACT, because you don't need to memorize formulas. You don't need to connect that. All right, guys, now let's go ahead and do an application problem, and I bet you will be able to do this like a beast. So look at this question here. We're going to use all of them. Sine, cosine, all these different shifts and everything. It says, write 4 particular equations for the sinusoid to the right using, and it says, cosine is a parent function with a positive vertical dilation. So that means I want to do this. Y equals positive vertical dilation just means that I want the beginning, my A, to be positive. A cosine, open parenthesis, B, open parenthesis, x minus c, close, plus d. I'm just going down the alphabet. All right, let's look at our wave. I think the easiest one to get first is to look at my high and look at my low. So the midline. How do I get the midline, guys? Yeah, perfect. Add the high, add the low, divide by 2. 15 plus 3 divided by 2. 15 plus 3 is, and when you divide that sucker by 2, you get, there it is. I got one of them. I got the midline. All right, so this is 9. The amplitude is from the midline to the high point, or the difference between the high and the midline. So what's the difference between 15 and 9? That's my amplitude. let's see, what's next? If I use cosine, I have to use like, how do I get my C if I use cosine? I use a what? A peak, a max. So what's the X value for those peaks? For any of those peaks, it doesn't matter which one. 20. Usually you want to use the one that's closest to the y-axis, but it's not a big deal. If you were to say 200, it would be the same. All right, I think I got everything I need except for the B. I get the B by doing what divided by what? Yeah, why'd you use 360 and not 2 pi? Because it's in degrees. Look at the x-axis. It's in degrees, guys. What is the period? I have a peak at 20 and I have a peak at 200. 180. Good. What's the period, guys? How long it takes to do one complete cycle. So from one max to the next max, or for one point of inflection increasing to the next point of inflection increasing. So there it is. I got everything I need. 360 divided by 180 is 2. So here's my equation. Y equals 6 cosine, open parenthesis, 2, open parenthesis again, x minus 20 degrees. Put the degree symbol. If you don't put the degree symbol, you're telling me it's a radian. Close your parentheses twice. Plus, what's the midline? 9. Can we do that? Yeah, I think you guys are pretty good at that. No. The next yawn's a demerit. So don't yawn. I'm kidding. I would never write a demerit for a yawn. All right. Cosine is a parent function with a negative vertical dilation. So now I want my A to be a negative. So guys, here's what I would do for that. Put a point at the points of inflection. Use a different colored pencil if you have a different colored pencil. Or if you different ink, or pencil and ink. And then wherever there's a max, put a min, and wherever there's a min, put a max. It kind of looks like DNA if this were a 3D model. So here's how you do that. Come on. If I told you I want, what do you want to call this color? Light purple? If I told you that I want the equation of that purple expression, that purple curve, but I want to use cosine, you get me one of the peaks. I have a peak at what degree? 110. And everything else is the same. The amplitude's the same. The period's the same. So the B will be the same. The midline the same. Everything's the same except for the C, guys. So I'm going to write 6 cosine, open parenthesis, 2, open parenthesis, x minus 110 degrees, close, plus 9. Now here's the big idea. They didn't ask for the purple curve. They still want that black curve. So how do I turn the low into a max and the max into a low? Put a what in the front? A negative. When you put a negative, when you were in algebra 2 and you put a negative in front of the f of x like that, your highs became lows and your lows became highs. Everything reflected across the x-axis. Yes or no? Are we cool? Oh, ask. I see. Is there confusion? Tell me. Ask. Oh, okay. Yeah, I did. I'm trying to remember, but I didn't. Did I ask it for a whole bunch? Yeah, I think I just asked it for one question. Now I'm going to ask for a whole bunch. Okay. So how do you feel about this, though? Do we feel okay, Ortiz? Okay. All right, here we go. Now I want sine as the parent function. So now give me the same curve. Give me the same give me another expression, but using sine. Everything else is the same, guys, except for the sine. So 6 sine 2, open parenthesis, x, and I got to put something else new there, plus 9. If I use sine, I have to use what? I can't use a peak. I have to use a point of inflection. But I need a specific one. Can I use the one at 155? Or not, sorry, I'm looking at the dark line. Can I use the one at 65 degrees? No. Why not? Because it's decreasing. I need a point of inflection that is increasing, or one that changes from concave down to concave up. Or, sorry, did I say that right? No. Yeah, I did. Concave down to concave up. Which one is that? There's two of them. I can either use the one at negative 25 or I can use the one at 155. It does not matter which one. Which one do you want to use? Negative 25? Okay, if I use the one at negative 25, then I got to put a what here? Plus, because it's minus a negative. 25 degrees. Make sure to put a degree symbol, and that's it. You're done. I'm going to go back to the light purple one for the next one, because the next one says a negative vertical dilation. So here we go. I look at the purple one. I'm looking at the purple one, guys. And I'm like, oh, I need to write it with a negative in the front. So I'm just writing right now the purple expression. 6 sine, open parenthesis, 2, open parenthesis, x. And I'm going to choose what point of inflection? At what degree? What's my shift? Yeah, say it out loud and proud. 65. Close it, plus 9. Now that's a light purple expression. Do I want the light purple expression? No. I want to have a negative in the front of that 6. So that purple expression will turn to that black curve if I put what in the front? Negative. How do we feel? Okay. Now check it out, guys. And by the way, notice, I don't know if you've noticed, guys. I hope that you've noticed that when you do your activities,